It sets its own pace. It beats on its own. It doesn't need the autonomic nervous system at all. Okay? But what the autonomic nervous system can and will do, it will affect it so that it meets the demands of my body. For example, since the heart muscle doesn't need the system to function at all, but wait a minute, are there times when I might need my heart rate to speed up or slow down? For example, if I'm going to go exercise. If I'm going to go exercise, I need the heart to meet that demand. And that autonomic nervous system will help with that. What if I needed my heart rate just to speed up and slow down all day long, just to maintain homeostasis? Does it do that? Yes. So this autonomic nervous system will have the ability to get these viscera to speed up and slow down, remain normal, whatever the case might be, without having to actually say every single second of every single hour of every day, do this, do this, do this, do this, do this, do this, okay? Because the viscera will do that. It's just that the autonomic nervous system will help. And what the goal is, meet the demand of the body. Because we have constant changing needs. As we are here in class right now, and as we're sitting, okay, your body doesn't have to meet the demands of sending as much blood to your leg muscles. So guess where a lot of the blood's going? To my viscera, to help them digest breakfast I might have eaten, snack I might have eaten, whatever the case might be. But then class will be over and we got to get up and we're going to have to start moving and walking, okay? Guess where the blood flow is now going to go? To our muscle, our skeletal muscle, so that we can have that muscle function. Decreases to the viscera and goes to the other parts of the body. At the same time, I now need to increase my blood flow. I mean, I need to increase my heart rate, need to increase my breathing rate. Blood pressure is going to get up. Do you see where I'm going with this? Okay, so whenever there's damage to the autonomic nervous system, this innervation that occurs, whenever there's damage, it can cause an exaggeration to the viscera. That exaggeration could be in either direction, speeding it up more, slowing it down more. So that exaggeration could go either way. And the response that that particular viscera can give can kill you. Okay? So, if you think about someone who may have had spinal cord injury, or maybe their spinal cord's been severed completely, what that's telling us, those nerves, wherever it may have gotten severed, okay, or damaged, or whatever the case might be, because we have control at these levels to viscera, viscera are affected also by spinal cord injury. Okay? So that becomes another issue that has to be dealt with when someone suffers spinal cord injury. Does that make sense? Okay? Because of their relationship to a spinal nerve. All right? So, just like we had in our skeletal muscular system, do you guys remember the reflex? Knee jerk and all that sort of stuff. This autonomic nervous system has a reflex also. This time, the reflex is to the organs themselves. So our viscera actually have reflexes, which is kind of cool if you think about it. Just like in the skeletal muscular system, it's unconscious, you know, it happens, and then all of a sudden, they're automatic, they're stereotyped, just like we saw with the skeletal muscle system. And this time, the receptors and the effectors are on the organs themselves. Once again, there's a reflex arc that exists. We got to have a receptor. We got to have an afferent neuron, integrating center, an efferent, and then an effector. Just like before, creating an arc for this response. This time, our receptors for the organs, we're going to have receptors that can pick up stretch. What organs of my body stretch?
Would the stomach be weak?
Stomach?
Lungs.
Lungs? The heart can stretch.
Intestines.
A little bit for the intestines. The bladder. Yes, most definitely. So we're going to find that these receptors, they can pick up stretch, tissue damage. Remember, I'm talking about my organs. Can my organs get damaged?
Yes.
How? Why? Which ones? All of them. They got to let us know that they're damaged in some way. The best example is always the heart attack, because it's, you know, for men, classic symptoms, not for women. Okay? But we might have the gallbladder hurt, might have the liver hurt, the appendix. Okay? So they got to be able to let me know when they're damaged. Another thing that this system's got to pick up on are blood chemicals. Any idea what that might be? The biggest factor about our blood is pH. Okay? The pH of our blood needs to be maintained at roughly 7.45. If not, lots of damage can occur. But that's a good example of a blood chemical. There's lots more, but that's the best example. Our body temperature, which we've already mentioned, roughly that 98.6, and then any other type of internal stimuli, something on the inside. So once it picks up information, the neuron is going to go to the central nervous system. We're going to integrate the information, and then the neuron will carry out a response for the central nervous system, and it will affect that organ. For example, increasing heart rate, respiration rate, blood flow, okay, to meet the demands of skeletal muscle. So we're going to have this whole, I mean, it's just so cool. So a lot of what the autonomic nervous system does is carry out some types of effects. It will go to the effectors to make those organs do something. In the reflexes that we're going to find, a baroreflex. Do you guys remember baroreceptors? Okay. Once again, a receptor, okay, a nerve ending, all right? And this time, since we're dealing with viscera, okay, organs, we're going to see the body really has to watch blood pressure. Do you happen to know why? Emily?
Those numbers determine how it's entering and exiting the heart, or how when it pumps, like when the heart is not pumping, the pressure, and then when it is pumping, the pressure of the blood. It's moving through it.
Okay, the numbers let us know the pressures that are there.
That was the question.
Do we know why it's so important, why we really have to pay attention to blood pressure?
Well, we can't oxygenate the rest of the body.
Depending upon that blood pressure rate, we may have a problem getting that blood through the heart, which means we're going to have a problem getting it to the tissues, which means we're going to have a problem getting the oxygen.
It can't be too high or too low.
Can't have it too high or too low. We're going to learn that this becomes very important to the overall function of our body. When we talk about blood pressure, we tend to think about that cuff that gets put on, and I don't know about y'all, okay, but when that thing starts to do this number and puff up and blow up and everything, I can't stand that feeling on my arm, okay, which I know it's got to be done, all right, but I guess because I know what it's doing when it's doing that, and I'm going, my poor blood vessels. That's what I'm saying to myself. So that pressure, that's what we think about. In reality, what it's doing for blood pressure, when we look at the structure of the heart, and as blood leaves the heart, when the heart beats, okay, the strength of it will determine how it's going to exit, make it over the aortic arch, and begin to feed the rest of the body. All right? Now, this tissue and this blood vessel right here, okay, is very important. All right? If it becomes under too much pressure, we can actually burst the vessels. Now, the other problem with this, the stronger the pressure coming off of the heart, that means that those arteries that are feeding tissues of the body are also under pressure. Meaning that as we get to the actual tissues themselves, that blood flow is under too much pressure.